Good morning, Old Middle Schoolers. This is Mr. Woolley, and we're going to have our video for Lesson 11 today. And send our disclaimer in. The information contained in this video is intended to be viewed by only the students in Mr. Woolley's classroom. By watching the video, you agree that you will not record or share the video with anyone who's not a student in Mr. Woolley's classroom. All right, so some rules for multiplying with signed numbers. Now we have this big display here. And you can think of it almost like an XY coordinate plane, with like this being our x-axis, and then up and down here being our y-axis. Now our x-axis numbers means the number of cards that we have or we're getting rid of, the number of matching cards I should say. So you have one card or two matching cards, three of them, four of them, you're going to draw these cards. Whereas here, these are you're getting rid of cards. Getting rid of one card, getting rid of two cards, getting rid of three cards. Now the up and down, the y-axis portion of this, is how many of those cards you have, all right? Or what's on those, I should say, what's on those cards. So for example, oh, there's a 1 on the card, there's a 2 on the card, there's 3s on the card. So this is how many you have, you're drawing. This is how many you're getting rid of, discarding. And then this is just what's on the cards. Positive number of cards you're drawing, negative number of cards you're drawing, all right? So what does this actually mean? Well, we'll say you get 3 cards that you drew, they're identical, and they each have a 3 on them. Well, let's go with 4. Let's go with 4. So you have 3 cards that have 4s on them. Well, if you have 3 cards with 4s on them, you're going to increase your score by 12. Because if you remember your multiplication tables, 3 times 4 gives you 12. So this quadrant here, quadrant 1, is all positive values, and it's drawing or picking up positive cards. It's going to increase your score. As we move to quadrant 2, it means you are getting rid of cards, and then now we can see what's on those cards if we go this way. For example, maybe I'm getting rid of 2 of my 3 cards. Well, that's going to drop me down 6 points, a -6. So it's discarding or removing positive cards. That's going to decrease your point total in quadrant 2. Quadrant 3, you're still getting rid of cards, but you're getting rid of negative cards. So say, for example, you're getting rid of 2 cards that have -4s on them. Well, if you're getting rid of 2 cards that have -4s, that's going to increase your score by 8 because your score is going to bounce back up. So when you originally drew those -4s, it pulled your score down, but now your score is going to go back up because you got rid of those -4s. So getting rid of negative cards is a positive situation for your point total. And then quadrant 4 we get into. What does this quadrant represent? It means you're drawing, you're getting cards, those are positive numbers, but you're getting negative cards. So say, for example, you got 5 matching cards that have -2s on them. Well, 5 -2s will drop you down 10 points. 5 times -2 is -10. So you treat them just like your old multiplication tables. So if you draw positive cards, it's good for your point total. If you get rid of negative cards, that's also good for your point total. And then quadrants 2 and 4 are going to decrease because you're getting rid of positive cards or you're drawing negative cards. All right. So notice how the quadrants have like Roman numerals. Quadrant 1, 2, 3, and 4. You'll see them written like that a lot in math. So obviously I converted them just our regular style numbers too. 1, 2, 3, and 4. All right. So what patterns do we see on the right-hand side of the table? Well, in quadrant 1, we get a positive score. In quadrant 2, could get a negative score. Obviously, if we kind of keep going along, quadrant 3 is positive. Quadrant 4 obviously is -2. So, and both of those on the right-hand side specifically, though, you could think about that we're just drawing cards on that one. So, all right. Enter the missing integers on the left side of the middle row. What do they represent? Well, that up here was how many cards we're getting rid of, how many cards are being discarded. All right, so is it possible to know the sign of a product of 2 integers just by knowing which quadrant each integer is located? Yes, because we already know that's a consistent relationship in there. 2 quadrants contain positive values, quadrants 1 and 3, and 2 quadrants contain negative values, 2 and 4. Which quadrants contain which values? Well, the positive ones are housed in 1 and 3. If you want to use the Roman numerals there, you can do that too. Negative quadrants 2 and 4. That's where you lose points. All right, then we're going to focus on how to turn some of these scenarios into real life problems. All right. So, for example, if you had -3 times 5, you could spend 3 of your $5 bills. So you're getting rid of 3 of your $5 bills, which means you're going to decrease $15, which means you spent $15. For example, here, like sometimes when you have like the two negative scenarios, the best way to describe it is like the integer game. You're removing or discarding 6 of the -3 cards in my hand. So you're getting rid of 6 of the -3s. Now that's actually going to increase your score by 18 points. Your score goes up 18 points. Remember, a negative times a negative does result in a positive answer. If you multiply with the same signs, it's positive. And you multiply with different signs, like we did in the first example, it's negative. All right, we have a 4 times a -7. Well, for 4 consecutive months, the man lost 7 pounds each month. All right, so that means then the man lost 28 total pounds because 4 times a -7, one negative sign makes it a negative answer. And overall, for 4 months in a row, this guy keeps losing 7 pounds each month. He loses 4 or 7, 14, 21, 28. So lost 28 total pounds there. So we can take these problems and turn them into something that is a real life scenario. All right, let's take another look at a couple of these. Explain why a -4 times a -5 is a positive 20. Well, think of the integer game. If you discard 4 cards, you're getting rid of 4 cards that each had a -5 on them, you're going to gain back 20 points. Because originally when you do those -5s, it dropped you down points. But if you're getting rid of those -5s, it's going to allow your score to bounce back up. All right. Number 3, each time that Samantha rides the commuter train, she spends $4 for her fare. Write an integer that represents the change in Samantha's money from riding the commuter train to and from work for 13 days. Explain your reasoning. Well, this is a key part right here. It says to and from. Now, she does this for 13 days, which means she's actually going to get on the train 26 times. Because to work 13 times and home from work 13 times makes 26. Or you could think of it as she's going to do this for 13 days. Well, she pays $8 a day because $4 there and $4 back home. So whichever way you want to kind of think about it, there's different ways to set this up. So we could say -4 because she spends $4 every time she gets on the train, which is 26 times. And gets you a -104. So she's going to be spending $104. Or you could say, well, she's spending $8 every day. $4 on the way to work, $4 on the way home, gives her the 8. And she does that 13 consecutive days, so she spent 104 that way. So 2 different ways you could have set that problem up. But definitely, this is where kids most of the time get tricked, is when this scenario happens. All right, write a real word problem that can be modeled by 4 times -7. All right, so here's an example. On Monday through Thursday, that's 4 days, so there's our positive 4. You spent $7 on lunch each day. So for 4 days in a row, you spent $7 on lunch. 4 times a -7, well, there's one negative sign in there, so it's a negative answer. When you multiply with opposite signs, it's negative. And that means you spent $28 on lunches. So, all right, thanks for watching. Go ahead and give the practice in Schoology a try.